Okay, so we will look at few problems on relations and functions. These are all easy problems, pretty basic problems to help you understand your concepts on functions. Okay, so try this one for a minute or so, and then we will discuss. Okay, let's talk about it. Okay, so here, when we look at algebra of functions, if you have, let's say, addition of two functions, you can operate them individually and then add whatever you get. Okay, so what do I mean by that? So f plus g of x, okay, it is as good as, sorry, it's two, what happened? What did I select? Okay, f plus gx is as good as f of x plus g of x. Okay, and then so f of x is given as x square plus x, and then g of x is 3x plus 4. So you just add them. Okay, it's just simple manipulation. And then you have x squared, and then x plus 3x would be 4x plus 4. And then if you can leave it as such, but if you want to write it as a plus b whole square, here you see x squared plus 2 into 2 into x plus 2 squared. So you can write this as x plus 2 whole square. Similarly, when you take a difference of the functions, you can operate on the input individually, f of x first, and then g of x, and then take a difference. Okay, so this will give you x squared plus x minus 3x, and then minus 4. Okay, so this will become x squared minus 2x minus 4. We can't do anything there, so we will leave it. Okay, so this will be your f of x plus g of x, and then this is f of x minus g of x. And then let's look at the multiplication. Okay, so here again, you do the same thing. Okay, you operate on x with the help of the first function, and then you operate on x with the help of second function. You just multiply. Okay, and then what do we have here? X squared plus x multiplied by 3x plus 4. Use the distributive property, multiplication over addition. So x squared into 3x would become 3x cubed. X squared into 4 is 4x squared. And then x into 3x will become 3x squared. And then x into 4 is 4x. And then we have two like terms. Okay, x square terms. So we can add them together. So you have 3x cubed plus 7x squared plus 4x. It's like just multiplication. Okay. But I think sometimes student gets confused when we are trying to manipulate this. Okay, multiply two algebraic factors. Are you guys okay with this multiplication? Harsha?
Yes. Yeah.
Sudhani, are you okay with this?
Yes, sir.
Okay. And then we have division. Okay, so division is again the same thing. Okay, so you take the first function and then operate. So operate on the input, and then again take the second function, operate in the denominator. So what do you have here? X squared plus x plus 3x plus 4. You can leave it like that, but the important point here is you need to write a small note as to what kind of values are not really acceptable. Okay, sorry, what kind of values are not acceptable? Okay, what do you think? What can when you have f of x by g of x in this function, a rational function, what kind of values are not acceptable?
Where the denominator is equal to 0.
Very good. Okay, so very good. So your denominator cannot be 0. You cannot divide by 0. So what you do is, you take this expression in the denominator, you say that I cannot accept if this is 0, right? So this must be not equal to 0. Right? So when is this 0? 3x is minus 4. And then x is minus 4 by 3. So your x cannot be minus 4 by 3. So you have to mention that. Okay. And then I think you are done here. Are we okay?
Yes.
Okay. So this is like straight manipulation. Okay. Now try this for a few minutes.
Should I tell?
Okay. So what do you have?
Domain as all real numbers
Okay.
and range as positive numbers.
All positive numbers. That means, can I say that, let's say number 1, will it be in the range?
Okay,
Will
no.
1 be part of the range?
No.
Yes, no.
It won't be.
It won't be, right? It won't be. Okay, so here if you see, we have an absolute value function, modulus function here. So this modulus function will always be positive, isn't it? This, okay, is either 0 or a positive number. This is always greater than 0, right? So that means the minimum value of f of x. What is the minimum value of f of x? Minimum value of f of x is 2. Okay. And then in x, you can actually supply any real number. Okay. So domain includes all the acceptable values. So x can be any real number. Okay. So the domain is, yes, as you pointed out, domain is your real number, set of real numbers. But when it comes to range, because x minus 1, modulus x minus 1 will always be positive or either 0. So the minimum value of the function starts from 2. Okay, so your values can be only be greater than or equal to 2. Okay, so your range will be 2 to infinity, and then 2 is included. Are we okay?
Yes, sir.
Yeah. Okay, so I will pause here. So try this. Okay. Now, when you have a square root function, because we are dealing with real functions, can I have a negative number inside the square root?
Until if it's complex numbers.
We'll get complex numbers. Very good. So if you look inside the square root, in order to figure out what acceptable values can x take, we can say that x square minus 16 should be greater than or equal to 0, right?
Yes, sir.
Then here we are trying to solve inequality here. So x square will be greater than or equal to 16. So we can say x square is greater than or equal to 4 square. Now, then what will be the values of x?
4 to infinity.
Okay, so 4 to infinity. Okay. So if I take 4 till infinity, suppose I have 4 here. So if I take any value greater than or equal to 4, and then these values will be greater than or equal to 16. Okay, are there any other values?
Yes, sir, negative value.
Okay, what are those?
-4 to minus negative, sir.
Okay, so
Minus infinity, minus infinity.
minus infinity. So you're actually going towards smaller numbers. So you should not say -4 to minus infinity. You should say the other way around, minus infinity to -4. You understand?
Yes, sir.
Okay, so the -4, and then these numbers are also acceptable. Okay, so in these two regions, we can say that x square will be greater than or equal to 16, right? So here we say x is either less than or equal to -4, or x is greater than or equal to +4. Okay, so the domain here, x belongs to -infinity till -4. -4 is included. Union.
Right.
Okay, so I need to take a square bracket here. So union 4 till infinity. Okay, so this is your domain. Okay, so this is your domain. Now, one more way to do this is, whenever you have this, you may want to split this into, let's say, two factors. Okay, so a square minus b square, you can write it as a plus b into a minus b. So you have x minus 4 into x plus 4 greater than or equal to 0. Okay, and then now you try to get something known as critical points. Okay, so what are those critical points? When is this left-hand side is actually becoming 0? Okay, so when does it really become 0? If I take x is equal to 4, it is going to be 0. Or x is equal to -4, it will be 0. So you plot them on the real number line. Okay, and then you have only two critical points here, -4 and 4. So if you look at the largest critical point, to the right, okay, 1 second. To the right of that critical point, any value that you pick, okay, any value that you pick will be, let's say, will be greater than 4. Obviously, it will be greater than -4. So the left-hand side will be positive. Okay, the same thing will happen when you take any value less than or equal to -4. Let's take, for example, a number. Okay, suppose if I take 5 here, what will happen to the left-hand side? 5 minus 4, and then 5 plus 4. Okay, which is 1 into 9. Okay, so any value which is greater than or equal to 4 is acceptable here. Similarly, if I take a number which is less than -5, -4, suppose -5, and then substitute here on the left-hand side. What do I get here on the LHS? -5 minus 4. It will make the first factor negative. At the same time, it is going to make the second factor also negative, -5 plus 4. So a negative into negative will be positive. Okay, so any number that you pick, which is less than the smaller of the numbers, will make each factor negative, and then you have only two factors, right? So if each factor is negative, they'll become positive. So you will end up having greater than or equal to 0 anyway. So this is another way of looking at this. Okay. Now this is the story of domain. Now what do you think will be the range? This function will give you what values? So if you start from, let's say, 4, the first answer that you will get is 0, right? If you substitute 4, you will get 0. Now, any number which is greater than or equal to 4 will make this x square greater than 16. And then the square root function will give us a positive value. Okay, so that means for all these values which are greater than or equal to 4, the function returns a positive value, starting with either 0 or a positive value. So similarly, I think since you are anyway squaring, whatever is true for values which are greater than or equal to 4 should also be true for values which are less than or equal to -4, right? Because you are just squaring it, right? It doesn't matter whether it is negative or positive. So from that, we can just say that the range will be either 0 or any number greater than 0. So we'll have 0 included. So I'm using a square bracket here and then infinity. Okay. We're okay with the range and domain here?
Yes.
Okay. So then, yeah, any questions here?
No, sir.
Okay. So let's move on. Okay, so try this one. 1 second. Okay, Harsha. So what is your answer?
Sir, the domain is a square bracket -4 and 4 and square brackets. Sir.
Okay, so domain, what you are saying is square bracket.
-4.
Okay.
4, sir. +4.
+4. Okay, so what is your
Square
range?
bracket. And range is 0 to 4, sir. Square bracket 0 to 4.
Square bracket 0 to 4. Okay. Okay, this is also square bracket?
Yes, sir. Square bracket.
Okay, so let's verify. Okay, so this is your domain and range. Sudhanya, you have any answer?
No, sir, the same one.
Same one. Okay, so both are you agreeing with the same thing? Okay, so let's do one thing. So whatever is inside, it has to be positive or 0, right? So 16 minus x square is greater than or equal to 0. Now, if I multiply both sides by negative, what will happen? Sorry, -1. The sign of inequality flips, right? So this would become x square minus 16 is less than or equal to 0. And then I take the factors, so I can write it as x plus 4 into x minus 4 is less than or equal to 0. So when is the left-hand side equal to 0? We have the same critical points, right? So we have the same critical points. So we saw that, okay, so -4 is one critical point, and then 4 is the other critical point. So you know any value that you take to the right of +4, it will make the left-hand side positive. Okay, because it makes positive, this is not acceptable for us. Okay, so we're going to ignore this region. Okay, but is 0 okay? I think equality is there. So 0, sorry, not, so 4 is okay. So 4 is okay because equality is there. So similarly, between -4 and 4, what will happen? Between -4 and 4, any value that you take will be greater than -4. That means it is going to make the first factor positive, right? Okay, maybe I think it's a good idea to write this a little more clearly. I will write x plus 4 as x minus -4. Okay, so that way I think we'll get little more clarity. X minus is less than or equal to 0. So now suppose if I take any value between -4 and 4, for example, I take, I think 0. 0 is a good number, convenient number. So if I take 0, the first factor will become positive because 0 is greater than -4. Okay, whereas the second factor will become negative. So you have positive multiplied by negative. I think you are getting a number which is less than or equal to 0. In this case, strictly less than 0. So 0 is acceptable. And any value between -4 and 4 will be acceptable. Okay, so I think this region is okay for us. And again, if you move to the left of -4, what would happen? Any value that you select is in fact smaller than either of these two critical points. Okay, so it is smaller than -4. It is also smaller than 4. So both the factors will become negative. So when you multiply them, you get positive, but you want less than or equal to 0. So this side is also not acceptable. Okay, so only -4 to 4 I think your domain is good, very good. And then range. Okay, so when you substitute -4 and 4, you know that it is becoming 0, right? Now, can you actually substitute values greater than 4? You're not allowed to substitute. So you're anyway substituting values between -4 and 4. You will see that the function value will become maximum when x square becomes minimum. Okay, so when is x square minimum here? X square is actually minimum when you take x as 0. Okay, so any other value to the right of 0 or to the left of 0 will make x square positive. Okay, if x square becomes positive, then the output becomes smaller, right? So the output is maximum when x is 0. And then as you go towards 4, the output decreases and then becomes 0 once x is 4. The same thing happens as you move towards -4. Okay, so you're right. So your range will be from 0 to 4. Very good. Okay, I think good. So let's move on. Okay, any questions here? I think both of you are okay.
Yes, sir.
Yes, sir.
Okay, so try this one. Okay. Okay. So what is your answer, Sudhanya? What is the domain?
I got -infinity to infinity.
Okay, so you are saying the acceptable values are -infinity to +infinity.
Yeah.
Okay, so that means any value is acceptable. That is what you're saying.
Yeah.
Okay, so for example, let me pick a number. Okay. Let's say, how about x is 3.5? Let's see. I'm just taking a number. If x is 3.5, what would happen to the expression inside? So what will happen? X square will become, what is 3.5 square? It will be 12.25. You're okay with this?
Yes, sir.
Okay, and then 7 into 3.5. Okay, so that would be how much? So 35 and then 21. So 24.5.
Yes, sir.
Okay, so 24.5 plus 12. Now, do you think, now let's add the positive numbers. Okay, so 12.25 plus 12 will be 24.25 minus 24.50. So then what will happen? Will it be positive or negative?
Negative.
It will be negative. So now, because I know the value where it fails, so I straight away hit that value. Okay, but this is not the right approach anyway. But yeah, it's actually very close. What do you say? Very thin interval where you find unacceptable values actually. So that is why I think it's easy to skip them. Okay, so how do we actually solve this? Whatever quadratic expression that we have inside the square root function, that must be positive, isn't it? Or 0. Okay, you start from that as you did in the previous problem. X square minus 7x plus 12. This must be greater than or equal to 0. Now, to identify the critical points, we need to factorize it. Okay, so it's easy to factorize this one. So you could write it as the minus 7x. I can write it as 4x minus 3x. Okay, minus 4x minus 3x. Why? Because I see that 12 can be split into 4 and 3. So we get minus 4x minus 3x plus 12 is greater than or equal to 0. And then from the first two factors, I'll take x as common, x minus 4. And then from the last two factors, minus 3 common. So I get x minus 4 is greater than or equal to 0. Now I have x minus 4 common. And I have x minus 3. So this is greater than or equal to 0. So now I have two factors greater than or equal to 0, multiplication of those two. Now, what are the critical points here, guys? Can I say 3 and 4 are the critical points?
Yes, sir. 3 and 4 are the
Okay, and then because I have equal to, this is the slack inequality, greater than or equal to. So 3 and 4 are included. Okay, so which I'm showing with that solid dot. Now, if I take any value which is greater than, sorry, what did I do? Any value which is greater than or equal to 4 will make both the factors positive. So this will give a region where I have acceptable values. Okay, so this is okay for me. And the same thing, anything which is less than or equal to minus 3 is also acceptable, because any value I take which is less than 3 will make each of these factors negative, and then negative into negative will become positive. So this is also acceptable. But I cannot take values between 3 and 4. Okay, so then you understand. So I cannot take
Yes,
any
sir.
value
Yeah.
between 3 and 4. So in your domain, the interval 3 to 4 is not acceptable. Okay, so your values have to be less than or equal to 4, or they have to be greater than or equal to 4. Okay, so but we cannot really say that this interval is small, 3 to 4, because we are dealing with real numbers. So between 3 and 4, there are infinitely many real numbers. Okay, so your domain X will belong to minus infinity till 3, 3 is included, union 4 and till infinity. Okay, so this 3 and 4, that interval is out of our domain. Clear?
Yes.
Harsha, questions?
No, sir.
Sudhanya, questions?
No, sir, I got it now.
Okay, yeah. Okay, so we'll move on. Okay, so now try this one. Let's talk about it. Any ideas here? See, when you have a rational function, what did we discuss?
Sir, the denominator should not be 0, so it
Cannot be 0. Very okay. So whatever values make the denominator 0, those values are not acceptable, right?
Yes.
Now, if you look at this, it's exactly the same quadratic expression, and then the expression will become 0 when x is 3 or 4, right? Okay, you don't want the denominator to be 0. And we have just looked at this quadratic equation in the previous problem. So when is this 0? When x is 3 or x is 4. So there are two values which are not acceptable. Other than these two values, all the other real numbers are okay. Do you guys get it? So that means
Yes.
what should be your domain? Your domain is any number from the real numbers set of real numbers, except 3 or 4. So what you do is you subtract them. Okay, so here you use curly braces to list down the numbers which you don't want. Okay, so you don't want 3, you don't want 4. So this is your domain. Okay, so all the real numbers except 3 and 4. So then, yeah, you're okay?
Yes, sir.
Asha, fine?
Yes, sir.
Okay, so try this one.
The denominator. of the denominator and the numerator.
Ah, okay. Okay, so for the denominator, if it becomes 0, does it really bother us?
It should not be equal to 0.
No. Yeah, sorry. The denominator will bother us. The numerator. Numerator, if it is 0, that's okay, right? As long as the denominator is not 0.
Not 0, yeah. Okay,
So
yeah.
that is okay.
But like not in, okay, yeah, that is generic case. Okay.
Yeah. So even if the numerator becomes 0, that's fine. Yeah.
Okay, got it.
Yeah. Okay, so try this one. Okay. Are we getting any ideas? Okay, I think there are two ways of approaching this. Okay, so then, yeah, you have any ideas?
Yeah, 1 second, sir.
Okay, yeah. So you want me to give some more time?
Yeah, just 1 minute. I'm nearly there.
Okay, yeah. Okay, so what do you think your answers are?
Square bracket 0, comma 1, round bracket.
Square bracket
0
0, okay,
and comma 1,
comma 1,
round bracket.
round bracket. So 1 is not included. Okay, so
No.
very good. I think you're right. So what did you do here?
I started off by getting the domain and then I found the range.
Okay, so what is the domain here? What are the acceptable values of x here? Can I take any x value, or what do you guys think?
Any x value, sir, for the domain.
Because your denominator will not be 0.
Yes, sir.
Okay, and then your numerator can be anything.
So you can take any.
So then, yeah, how did you arrive at this range? Oh, I think there's some audio issue. Okay. Akshay, I think, yeah. 1 second, actually. Okay, we will pause. Okay, yeah. Okay, we'll pause. Akshay. I think she is having trouble with.
Okay.
Okay, that happens. Okay. Okay, so I think as we were discussing, any value of x is acceptable, right?
Yeah, because x square plus 1, so it's always greater than 0.
Yeah. So now, how did you arrive at the range? What did you do?
So when we first have to, when we say that all values of x square plus 1 are greater than 0,
okay,
then I put values in, like as in trial and error, I would say almost. Okay. And since all values are greater than 0 and it's a fraction and the denominator is greater than the numerator. So it will always be between 0 and 1. And it's never equal to 1. So that way.
I think that's good thinking. That's good.
I do like more logical instead of actually calculating it.
Yeah. But I think that's fine. Asha, you follow what Sudhanya did?
Yes, sir.
Because what she's saying is actually nice. So if you look at the numerator, that's always one smaller than the denominator. So obviously it cannot be 1. Okay, and then x square is always positive. So I mean, when I say x square is always positive, other than when x is 0. So you have to start with 0, but this can never become 1. Fantastic. That is completely acceptable. Okay.
it is acceptable, but the presentation of that is not acceptable in school.
Okay.
So that's the problem that I have.
We'll work with that.
Yeah.
Work with that. Okay, don't worry about that. See, so if let's say your teachers are worried with that logic,
Yeah.
but they shouldn't actually, to be honest, they shouldn't be worried because the logic.
It's like I can tell in words, but when I'm trying to write that down, it's not always conveyed properly. So I need to know how to write that step by step.
Achha. Okay, so maybe what you can do is, let's say one way to deal with this is, this is a real function. Okay, so you're going from R to R. So my f of x, so the given is x square by 1 plus x square. So here, maybe what you can do is, in the numerator, you can add 1 and then subtract 1. Do you see that? That is okay?
Yeah.
But I think in school, when you're presenting, you should do this in the next step. Okay, so you should not be stingy like.
Yeah. Okay.
So here, what do you get? I think the first 1 plus x square by 1 plus x square is 1, minus you get 1 by 1 plus x square. We see that now?
Yeah.
Now we know that all values of x are acceptable, right? Now, how does your x square look like? X square is always greater than or equal to 0. You take any value, right? It's a quadratic function. Okay, so it looks something like this. Right? What happened? X square graph, I think it looks like this. You take any values greater than or equal to 0, you get greater than or equal to 0, less than 0 also greater than or equal to 0. So it's always 0 or positive. So in that case, you can say that because this is always greater than or equal to 0, you can claim that the denominator here, okay, 1 plus x square is always greater than or equal to 1. You're okay? Are we guys okay here?
Yes, sir.
Yeah.
So that means now, if I take, let's say, for example, if I take a number which is 4, if it is greater than 2, when I take reciprocals, what will happen? I take reciprocals on both sides. What happens?
1 by 4 is lesser than 1 by 2.
Lesser than. So now maybe you can say 1 by 1 plus x square is lesser than or equal to 1. Can I say that? Are we okay?
Yes, sir.
Yeah.
Now that means what? This function, if I take 1 by 1 plus x square is 1, suppose. If I take 1, then I'll get 0. Then I'll get 0. And then if I take, okay, so if I take, let's say, equal to 1. Okay, now when is it equal to 1? When x is 0, right? When x is 0, it is equal to 1. When I do that, this will become 0. See, the extreme cases are what? 1 by 1 plus x square will become, maximum it is 1. Okay, but now when you take less than or equal to 1, what is the minimum value here? What is the minimum value of this? What is the minimum value of that?
Greater than 1, sir. Equal to 1.
No. See, what is the minimum value? X is increasing, right? Here.
Yes, sir.
X square is increasing. Suppose you take a very large value, what will happen to the denominator? If I take a very large value, what will happen to the denominator? Denominator will also be Very large. If the denominator becomes very large, what will happen to this entire value?
It becomes very small.
Very small, right? So can you see that this is kind of approaching zero? Do you see this approaching zero? Are you getting? But can it ever be zero? Tell me.
No, sir, it cannot be.
It cannot be zero. So I can say that it approaches zero, but there is no way it can be zero, isn't it? So then you understand what I'm saying here.
Yes, sir. Yeah.
Okay. Now another thing directly what you can say is, since x square is positive, my left hand side can never be zero. That you can say, but I think if you take a look at the quadratic x square graph, you'll get a better appreciation that when x becomes really large, the denominator will become really large and the entire fraction will become very, very, very small, but it is never going to become zero. Okay, because it is never going to be zero, this is actually translated to this. So that means 1 by 1 plus x square will lie between 0, but 0 is not included, and 1, but 1 is included. Okay. Now, if 1 by 1 plus x square is between 0 and 1, what can I do? Okay, if I take the minimum value 0, the maximum value of f of x will be what? Maximum value of f of x will be, the minimum value is 0, so maximum value of f of x will be 1. Is that included? Is this 1 included? Harsha, is this 1 included?
No, sir, it isn't.
So then you understand, because 0 is not included, 1 will not be included.
Yeah.
Okay, so you can say that slightly smaller than. Okay, so we have to understand that the maximum value is not 1, it is approaching 1. Okay, it's like slightly smaller than 1. Slightly smaller. Minimum value. What is the minimum value of f of x? I want to take maximum value here. Okay, if maximum value is 1, minimum value is 0. Okay, so that means your range is correct.
Sir, what's 0 square, sir?
What is that, Harsha?
0 square.
0 square. Why 0 square?
Just asking, sir.
It's a 0. What is 0 square you are saying?
Yes, sir.
0 square is 0.
It's 0. Then how is it possible?
How is it?
Possible here, if 0 square is 0, then it would be 0 at top. Then the value would be 0, right?
No. So where are you looking at that?
Sir,
Here.
no, sir. The question x square by 1 plus x square.
So if x is 0,
Yeah.
is it acceptable or not?
But in the sorry.
Denominator, you have this 1, that is making it 1.
In numerator, sir.
Numerator can be 0. That's not a problem. No? See, suppose you are just substituting x is 0. Your numerator is 0. 0 square is 0. And in the denominator, I have 1 plus 0. That is perfectly okay, right? So that's 0. 0 by 1. That's 0. That's okay, no? You're getting?
Yeah.
Harsha, are you okay?
Yes, sir. Yeah.
Sudhanya, are you okay?
Yes, sir.
I think when you represent this as a solution, maybe explaining this will be important. Why 0 is not acceptable?
Yeah.
Okay. But there is another way of looking at this problem. Okay. Because this is a real function, suppose if I take f of x as y. Suppose if I take f of x as, what is that? If f of x is y, I'm going to write y as x square plus 1 plus x square. Now 1 plus x square is positive, isn't it? So because it is positive, I can just do a cross multiplication. Okay, so I can write y plus yx square is equal to x square. Now here I will get a quadratic equation in x square. So I'll get x square into y minus 1. So the right hand side x square, I'm taking it to the left hand side. So x square into y minus 1 plus y equal to 0. Now, in 10th class, you learned about discriminant. Harsha, did you learn about discriminant?
Yes, sir.
Okay, so here you have a quadratic in x, right? If you have a quadratic in x, there are two things, no? Your general quadratic expression says what? Ax square plus bx plus c equal to 0. If you want, okay, real values, you know that x is real, isn't it? X is real. If x is real, one condition is your b square minus 4ac should be greater than or equal to 0. That is one condition. The second condition is because you have a quadratic equation, your a has to be non-zero. Because otherwise you don't have a quadratic equation, isn't it? Are we getting? So then here you see these two conditions?
Yeah. Yeah.
Now, if you come back to this quadratic equation that we wrote here, what is the value of what is a? A is y minus 1, isn't it? If I look at the second condition, if I have to satisfy the second condition, I know that y minus 1 cannot be 0. So that means y cannot be 1. Okay, so that is why we are not including 1. Okay. And then if I use the first condition, that the discriminant has to be greater than or equal to 0, b, there is no b here, right? There is no b. So, sorry, there is b? No, there is no b. There is no x term. I think I thought I saw x term. There is no x term here. Okay, so b is 0. So 0 square 0 minus 4ac. So I have 4 into y minus 1 into y is greater than or equal to 0, right? Now, both sides I have, both sides I'll multiply, I divide by minus 4. Okay, I'll divide. Okay, so I'm dividing by a negative number. So what happens to the sign of inequality? It flips, it reverses. So I'll get what? Y minus 1 into y.
So I think plus y, no?
Plus y?
Yeah.
Y beta? B square
X square.
4ac, right?
Okay. Yeah. Got it. Yeah.
Right? So this will be less than or equal to 0. We're okay? Now, what are the critical points here? The critical points are 0 and 1. Okay. I think we saw this earlier, right? Whenever you have less than or equal to 1, let's say if you put critical points 0 and 1, you know that these values are not acceptable. Remember? These are not acceptable. Only the values in between are acceptable. Now, when the values are in between acceptable, that means your y value will be between 0 and 1. And we have already established the fact that y cannot be 1. Understood? So that means it can only be from 0, including 0 till 1, but 1 is not included. Okay, so then you understand. So this is another way of getting the solution using quadratic equations.
Yeah, I had done half of this, but then I thought it was too long. So I just looked at the question for a while and then I got that one.
Yeah, this, I think your teachers will be happy if you present it this way.
Yeah, this is the way they've taught as well.
Yeah. Okay, so, any questions here?
Awesome.
Okay, so then you're also okay?
Yes, I'm okay.
So, TK, so what I'll do is, I think we will stop here.